Okay, this next problem is the same thing. So it says the incubation time. Oh, and by the way, this part A is part of number 47 in your book, which is actually one of the extra credit problems, so just FYI. Okay, so it says the incubation time of a fertilized chicken egg is normally distributed. That means we get to use the curve, the normal curve, distributed with a mean of 21 days, standard deviation of 1 day. Okay, so remember the way I like to do these is I like to put the z-scores and the raw data down here. It doesn't really matter which one you do first. I'll go ahead and do the z-scores. Remember the standard, whoops, that's supposed to be straight. Standard z-scores are 0, 1, 2, and then -1, -2. Okay, so that's my z data. And then my raw data for this problem is 21 is the mean, standard of 1 deviation, so that means this one's going to be 21 plus 1 standard deviation plus 1 is 22, 23. This one's going to be over here 20, 21 minus 1, and then 19. All right, so it says determine the 17th percentile. So remember, percentile means that and down and lower. So 17th percentile is, and this is just sort of a guess, and you might actually put it on the wrong side, but I'm going to say that it's going to be right here somewhere. So this would be 17%. Okay, so what do on your chart is you look on the inside of your chart, and because that's where the areas are. And so get as close to 17 as possible. Okay, I got it. It's -0.95 and that's 0.1711, and I think that's as close as we can get. So that's at -0.95. So my z-score is -0.95. And I did put the line in the correct spot because it would be just inside the -1. Okay, so now we have to translate that into raw data. So remember how that works is we use our formula. I'll write the pathway here in a second, but we use our formula. Z equals whatever we're testing, minusing the mean, divided by the standard deviation. Okay, so we found Z. It's -0.95 equals, we are looking for the raw test data, this thing right here. Minusing 21 divided by our standard deviation is 1, which is nice. A little bit easier to calculate. So all we have to really do is add 21 to both sides, solve that little equation, and I'm going to get the test equals, what did I get? 20.05. 20.05. And so make sure everything jives in your picture. 20.05. Does that fit in the picture? Yeah, because it's going to be somewhere between 20 and 21. That looks good. The z-score also looks good. It's going to be somewhere between -1 and 0, which it is. And then so this area, 0.17, goes with -0.95, which in this problem goes with 20.05 days of incubation. Right? So that's how you go back through the pathway. So remember, here's the pathway. It is the raw data to the z to the probability or the area or proportion or some word like that. And remember, we on these problems are going backwards, so you can go up and down this thing. So to give from raw data to Z, you use your formula. And this part of the pathway, you use your chart. So you'll see me drawing this all the time, but this is the pathway. All right, so let's do that again. It says determine the incubation times that make up the top 8% of the eggs. Okay, so let's draw our regular, our normal things, our normal z-scores. So they're just going to be 0, 1, 2. You can put it on the other side, but we're not really dealing with this side on this problem. Okay, so where would 8% be? I'm not quite sure. Is it going to fall in between 0 and 1, or is it going to fall between 1 and 2, or is it even going to fall outside of 2? I'm not sure. This actually might be a time when they give you the area, you might actually want to put it in pencil, because sometimes you might not put it in the right place. So I'm just going to put it right here, and I might be just guessing. I might have to actually move it over past the 2 or in front of the 1. So really I'm just sort of guessing where it's going to go down there. Okay, but remember what happens when we're given the right side is our Z chart does not read on the right side, so we have to go over here and get the left side. So what would the left side be? It'd be 1 minus 0.08, which is going to be 0.92. So in order to find this Z down here, I have to look up on the chart of 0.92. And so find as close to 0.92 as you can. 0.9, okay, I got it. It's 1.41 is going to be the closest. So this Z is 1.41. Okay, and so we're sort of in limbo right now in our little chart over here, because we've gone from the area or the probability or the area to the Z, and now we got to get that raw score. So how do we get from Z to raw scores? We use that formula. So Z equals test minus the mean divided by standard deviation. Okay, so my Z in this case is 1.41 equals whatever we're testing, minusing 21 divided by, again, 1, which makes that problem actually really nice. Okay, so this is going to be 1.41 equals test minus 21 after we cross multiply, and just add 21. And so our test is going to be 22.41. All right, and so I didn't actually finish my picture because I didn't put the raw data on there. So I put the Z data, but I didn't put the raw. So this was my Z data, and now this is going to be my raw data. My raw data is 21 at the mean, and then our standard deviation is 1, so that means this is going to be 22, 23, and on the other side you can do it too. It's going to be 20 and 19. All right, and so where did this line come down? It came down right inside the second standard deviation, so that means right inside 23. Does that work here? Yes, it does, because that's in between 22 and 23. So those all match. 92% to the left is equal to 1.41 in Z world, which is equal to 22.41 in egg incubation world. So in the raw data world. Okay, so on to the next problem.